There's a few slides. I'll also have some demo as well to go through. But so this is kind of applying static analysis. So this year I decided to kind of have this part actually happen after we've gone through a lot of the static analysis. So pretty soon, I believe, not this week, but next week, we're going to start on doing malware analysis inside of virtual machines, basically while the malware is running and that type of thing. So in this case, applying your static analysis, so using all the different things that we learned, we were talking at the beginning of class about you know, the OBJ dump output, the import tables, and also some of the other metadata that's available. In addition to that, you know, we had a number of you know, a number of examples where we use Yara to try and extract matching features from malware and try and use that to basically build signatures that can do detection and everything. So, you know, for us, we'll say that, you know, we can pull a lot of that information, try and document unique contents that can be used to detect copies of this malware family elsewhere. You can use it to describe the purpose, functions, even the threat level of malware. So for instance, if you know that malware is, say, implementing certain capabilities and things like that, you can use that to partition this malware as more dangerous than another type of malware. You might be able to partition the ones that can monitor microphone and monitor camera and monitor keyboard from the ones that are just on your system trying to be a nuisance. And so the other thing is you can build a utility that could extract structured metadata from future samples as well. So I'm going to discuss some programmatic approaches that I use very frequently to achieve these ends. There's a large number of tools out there to provide this service. So there's, you know, I'll throw some out there. I believe even today, this wasn't always the case, but today, Cuckoo Sandbox even implements a large amount of static analysis and feature extraction and things like that. So I'm going to probably be low level and not employing a lot of those tools right now. So instead, we'll focus on doing like feature extraction and cataloging and stuff like that. So the data management. So again, we're going to be dealing with, say, a lot of malware samples. So what I like to do when I come up with a way to extract some data, so a good example would be, you know, I'll just kind of go back here, right? Wrong. There we go. That's the one I'm looking for. So let's see if I have some in here. If not, I've got, yeah. So I have like this one, and I think I use this one in a right. I think I used this particular sample in one of the lectures earlier, right? So we went through this, and you're able to identify a bunch of different, say, features here, right? So one thing that we might want to do is, I believe that it was mentioned that maybe this thing right here would be a useful feature to extract or something, potentially. Maybe the start address would be a useful one to extract, or maybe even this one, the image base, right? So maybe that would be a useful feature to extract or something like that that might be informative. So let me go back to that. So for instance, I might I'm just going to do this. So, you know, of course, try and improve my extraction. So I can like pull it out that way, right? So then I basically have a what amounts to an extractor for that particular thing, right? I need to be able to type in order to be able to do that, but there you go. So then we'll just do this for now, and then move on later. So now I've got like a tool that might be able to extract that particular image base, right? So so then think is it here? No. So bear with me a second. I think I've got I'll go into my test samples. There we go. So I've got like 10,000 malware samples in this folder, right? And the command, I'm just basically navigating through here. So one of the things that I can do, and I'll just kind of do this really quickly to show you, is this. So I'm going to basically look at all the files, and then I'm going to run, the Unix file command that basically tells me what type of file it is. So I have a folder that's full of a bunch of malware. Like I mentioned at the beginning of class, malware comes in all different varieties and everything. However, the tool I just wrote, that particular tool, is only designed to extract the image base from an exe file. So what I'm doing here is I'm looking through here, and as you can see, I have a bunch of samples that are HTML documents. Some of these are PE32. One of them's an XML document. One of them is just text, it says. So what I want to do here is basically get to some of the executables. So I'll just do like this, give myself the executables, and then I'm going to maybe pick like the top 100 of them, right? And what I'm going to do is I'm going to make a folder to put these in. So I'm going to basically take these, I'm going to grab the top 100 of them, and then after I've grabbed the top 100 of them, I'm going to extract the file names, which is everything to the left of the first colon character. So everything that's in the first field delimited by the colon, and then I'm just going to and then that should copy like 100 of them in there. Whoops. Oh, I forgot one parameter. Apologies. So then that'll copy like 100 files into that directory. The reason I'm doing this is I want to pull out a bunch of EXEs that now I would like to run that script that I just wrote against every single one of them individually to try and see if if that'll work. So taking a little while, but I think there's let's see. So they're all in there. So oh, I know what is happening here. This thing is just I'm gonna kill that. So I've got about 100 files in here. So now, what did I name that thing? I called it extract image base. So if I was to run that extract image base on this random file here, I'd get another image base, right? Or I'd get, this one actually happens to share the same image base. However, that might be just be an artifact that's introduced by Visual Studio. That might just be a common thing. So what I might want to do is do something like this. So you can see some of them, there's some errors for a bunch of them. So so all of them basically have the same image base, which may or may not be a good thing. I'd want to run the same type of analysis, and I can actually do this to show you what the counts were. So 96 of them, right? It looks like 96 of them have that image base, and then a few of them actually never bother showing that particular feature. Right? So this is a good way for us to try and answer that question of, is that particular value significant or insignificant? Likewise, I might grab one of these things. You know, I'll just look through this folder again. I might grab one of these things and maybe look for some other feature, like I believe we were talking about the first thing I'd mentioned was like the start address, so maybe the start address might be significant. So let me go and edit my script, and then I'll just look for start address. And then, let's see. So you can see in this case, I end up having some that actually repeat. Like this particular one happened 7 times, and this particular one happened 8 times. In fact, I can sort with a numeric range to give me an idea of kind of how, you know, how frequent some of them are, how frequent some of them aren't, that type of thing. But now basically I've written something that allows me to extract some data from the you know, from the code. So I might clean this up a little bit more just to I think it's like this. It's the 3rd field, I believe. So I might clean this up a little bit more. And you can ignore some of those errors that happens from time to time. So now what I've done, and I'll just kind of show it to you without all the extra filtering. So I've written something that literally extracts just that number and outputs it. So a lot of times what we'll end up doing with malware analysis is, number one, we're going to have a large number of tools that can extract information for us like this. This particular example is a very simplified one. This is kind of very simplistic, like very typical one. I'll actually go up here, and it's so common, in fact, that I believe this is the original version. Yeah. So it's so common, in fact, that this person actually wrote a Python tool that I'd recommend you look into because it'll be very helpful for you. And this Python tool extracts or allows you to extract all of the header information from an exe file if you give it. So that thing that I'm doing with a very simple shell script that's running kind of grep and using cut to do the text slicing, this thing will actually go in there and provide you the ability to extract a lot of that information. Or, if you will, this allows you to do a lot of the lookups that are implemented in that Yara module for PE files. So if you remember, there was that Yara PE module, and I'll just bring it up as well. Yep. So here's someone's already searched for it, so I don't even have to do that. So if I go in here, the PE module ends up allowing me to do matches on those things, right? So, you know, and then it's got a bunch of constants that are defined and everything like that. So anyway, the big reason why I brought this up, and now I'll get back to the presentation here, is because it's you're going to start to pick out data points where you're like, I want to know if this is significant or insignificant. So we pulled out two, one of which looks like it was insignificant, which was the image base address. Every single file that I have in that folder, or at least the 100 that I extracted out of it, seems to have a image base address of that 400,000 hex, which isn't uncommon. I'll just kind of add in that spoiler alert is I think that's one of the defaults for Visual Studio when you create a new project. So that's why that's showing up with that value so much. Interesting thing would be any cases that actually deviate from that value and use a different value, which may be few and far between because people like to stick with the defaults if that seems to be working, but some people like to change that value around too. So you're going to end up collecting all these little data points, and you're not just going to want to have them sitting in text files or sitting in spreadsheets and that type of thing. So what I usually try and do is I try and leverage, balance the ease of use and ease of deployment with flexibility. So the first two that are listed up here is actually Sqlite, which many of you may be familiar with, is a very lightweight SQL library. It actually turns any program that you link it to into its own little kind of mini SQL server. So it's not listening on any network ports unless you want it to, but it actually runs a server process in the background that can handle a lot of these queries that you're hitting back and forth with it. It also will maintain a little database file and everything like that. So that one's really nice because you don't have to admin and set up and configure a SQL server, which can be itself a project, and it's portable. So I can have this little SQL server or SQL program that does SQL-like queries. I can evaluate all that in a program that compiles and runs in Windows or compiles and runs on Linux, etc. And I can move it from Linux system to Linux system. So it's very nice from that perspective. And then the side benefit that it has, which is why I like using it a lot, is that I am writing all of my lookups in SQL, which means that it makes my program very easy to translate to a much bigger database engine if I need to. So for instance, if I wanted to start working with lots of data and I can no longer fit it on one computer, I may want to try and make use of one of the relational database systems that Amazon offers or something like that, and I'll upload all my data in there and then run the queries against that. So building around SQLite gives you the feature of having you write your program in a way that'll lend itself to that. So this is kind of more beneficial from the research perspective. MongoDB is another one that I like a lot. They actually just started, I think in the past few years, offering hosted cloud services for their database as well. It's not SQL, but it stores and represents everything in a very easy JSON format. So that makes it very easy if you are trying to build web applications around your data. It makes it very easy to basically import your data and then present it. So that's why it's extremely popular for a lot of those cases. It's also very easy to just install and set up, and then doing the database creation and destruction and management, all that stuff is very easy as well. It doesn't really maintain any, I would say it's very weakly typed, which means that it doesn't force you to define the structure out like an SQL database would. So it's very easy, if you don't know kind of where your research is going to lead you, to organically grow data entities or data objects out without necessarily constraining yourself by type choices and column choices and all that stuff. So two projects that I'll point out are also really good, and there's actually a third one now, which is called Yeti, like the drink cup, or the what is it, the abominable snowman or whatever. So that's another one that didn't make it up here because I only learned about it a few days ago. But these two are really popular ones for managing the data work that has to do with the security domain. So they come pre-configured with a lot of built-in data structures and built-in kind of object schema for managing security-related stuff, including malware. But in both of these, the crits and MISP systems, malware is one entity of many that are capable of being stored in there. So the reason I have these up here is just that these end up being more kind of polished applications. I'm not really going to use them in the class a lot, but if you want to play with something, or if you want to pursue some, improving some project in the security space, these are two good ones to kind of set up yourself and work with to try and see how other teams are doing it. I'm going to stick probably with a lot of the kind of lower level stuff. So the other thing, and I didn't get into this too much yet, but I will now. The other thing is when you're dealing with a lot of samples, dealing with a lot of malware samples, and you may have noticed that when I have all these here, every single one of them actually has this, what looks like a unique identifier of some sort associated with it. So what this is, I can see, I might have to try this twice just to see if I get it correctly. That's not it, so it's going to be this one instead. Or maybe not. I don't know. There you go. That's the value. So in this case, what they decided to do was run in Md5 Checksum, which is a very simple, typically used for file content verification or validation, but it's a very common, very simple, very easy routine that basically computes the checksum of the file. So as you can see, what they did, rather than storing it as whatever the file name initially was, which I might actually be able to extract from it maybe. Yeah. So this thing called itself inbox toolbar setup, right? That was what the program maybe was shipped as, was a inbox toolbar setup or inbox toolbar.exe or something like that, or setup.exe. That probably would have been the name of the file when it was delivered to the target, when it was run on the system. But what they've done here is they've actually calculated the Md5 checksum or whatever that is, and they store it as the unique identifier of this file. And so the whole principle with any sort of checksum value is that if you change the content of the file slightly, then there is a very unlikely chance that recomputing the checksum will give you the same file, or will give you the same value, which is kind of the principle with it and why it's used for verification. So a lot of people will use it. I'd say probably the most common place that any of you have seen it might have been when you're downloading really large images, like CD images or files from the internet, and they also supply the checksum value to make sure that you can use that to compare to whether or not the download completed without corrupting the file.
What is the significance of this one?
So,
Analyzing malware.
So the significance of it, and the reason why they're using it here, that's a great question, is that this provides us with a number that uniquely identifies this file contents. So getting back to the database example, if I'm going to start storing all this information in the database, I want to have like unique identifier to associate with the features or the data that I'm extracting from the file. And so for instance, if I wanted to call the malware notepad.exe, if we wanted to, however, I can call many different files notepad.exe. So from my perspective, if I have 7 different files hitting my users and all of them are called notepad.exe, I don't necessarily know if they're all related. And if I try and put them all in the same folder, it'll basically be a race to see who overwrites what and which version of notepad.exe ends up being the one that gets stored in there. So Most of the time what I've seen is they'll use one of these 3 algorithms. I just have like a link to them in case you wanted to see the math behind them. You're probably also familiar with some variant of these in the either networking or data encoding classes. But almost exclusively, I'll see kind of malware storage, malware analysis storage using one of these values as the basically the unique key or the primary key. Let's use the SQL term, primary key for data management. So go on to the next slide. So as I said, I like, MongoDB is one that I like a lot. It doesn't enforce like schema definition and planning up front, so it means I can just jump into storing my information in there. And then later on, if it turns out that I need to add a little bit more rigor around it, I can actually do that after the fact rather than having to think that through ahead of time. The benefit to that is I get all the data in there. If I have to restrict myself ahead of time very often, I find cases where data that I didn't predict when I defined my standard prevents me from storing that data in the database, and then I just have to reject storing that, so I basically have an information gap or I lose something. So
Could I Google that?
yeah.
So I mean that unique identifier and just to find out if some of the analysis have seen the
That's great. That is actually a very great thing for us to try. So this particular one, right, I got it a while ago. So it's, it says 1992. That's actually false. And we can get into that later, but it's still a pretty old file. So if I go and search for this checksum here, I can see that it actually showed up here on VirusShare, right? I don't know if I can grab like another one in here. Some of these may not have been analyzed. So a real common thing is if I go back to our threat miner, right? We'll do that. Because threat miner is that one that I showed you doing the malware research online. So if I go here to apt notes repository, and then I look at this thing, this one actually has, these checksums here. And so this is a great example where this particular checksum actually shows up a whole bunch of times. So you can see hybrid analysis, which is an online analysis system that's run by, I think it's called Payload Security or something. It has its analysis here. And then IBM's X-Force database also has some information. I forget how to get out of this. So this one's got some sort of information. I'm not exactly sure what. So, I don't know. Some of them are more verbose, some of them are more terse. Yeah, here's IBM has the Pyeongchang Olympics targeted spearfishing campaign. Securing Tomorrow, so McAfee also has some thing that they wrote about it too, which is the original document, if you remember. So, and yep, this company as well. So as you can see, there's a whole, and then here's the original link I was pulling from, right? So as you can see, there's actually a whole bunch of these things that allow you to pivot back to find what you're looking for. So this is kind of, what I'm saying is internally, it's very common to use those values to try and get, to try and import the data, or I should say to try and organize your data set.
So that tells me that the malware that I'm analyzing is not known. Not all those
Correct.
analysts have seen it before.
Yep.
Yeah.
Yep. And that's actually very common. So that's a, I would say that's another popular thing for people to do when they're trying to analyze something. So for instance, if I was to do, so if I was just give random data and checksum that, we'll see what happens here. I haven't actually tried this ever before. Didn't match anything, right?
That's what you get for a number.
Yeah, because nobody has found that. So that's kind of how that works. It's supposed to give you a high level of confidence, not absolute certainty, but a high level of confidence that whatever you're looking at is identical, and also that won't, have minimal collisions, if any. So the theory with MD5 is that it's collision free. The reality of it is that there's no way that it could be. It just ends up being very unlikely. That's the reason why you have like these 3 different ones, and some people insist on using the latter one, the 256, because it ends up having a bigger key space. You have a question?
Yeah, I was just going to comment, on the programs you have there, it's totally possible to, that they're just encoded with something different, so that's why we're not finding them. I know that the website used SHA-1 for checksum for the one you looked up, but
yeah, that's a really good point too. So he's saying that, and this is part of the reason why I have all 3 of these listed up here. Some of the analysis sites and that hybrid analysis might do it, because I think that I run into that a lot. Oops. Some of these analysis sites may not actually report all the checksums. So like this, in this one's case, it happens to have, I think, the Md5 checksum in a, or something, or the SHA-1 actually listed as a doc in the file name. That just is a coincidence that somebody decided to name it that. But the only checksum they actually provide here is the SHA-256. And that's because they are working off of the fact that the likelihood of a collision in this checksum is much less than the likelihood of a collision in the Md5 algorithm. Say in practicality, within any of your individual lifespans, is going to be very unlikely that you're going to end up running into a collision. That said, they like to publish it this way, which means, as he was saying, that if you are trying to search for, a checksum, it might befit you to search for all 3 of them to get a complete, basically a complete document fetch. So, let's see. Let me go over here. So, yeah. So, it's internally. Mongo also has a JavaScript engine that is responsible for doing the querying and command line interactions. So under the hood, it leverages JavaScript a lot in order to get a lot of the querying work done and provide you with a command line interface that's both familiar and powerful. So in this case, rather than coming up and inventing their own language like SQL did with the SQL language, they're actually just using JavaScript, and then you provide JavaScript with certain data structures to try and get the information you want. They have a couple Python modules that work really well, and then they also have like Go, if you're a fan of Go. Also, they have like a C API and all that stuff too. You can see all the APIs here, which is very useful. Beyond just the scope of this class. I use PyMongo a lot because it's pretty easy, straightforward, and it basically gives you a Python way of interacting with the database. The reason I like that is because just like I showed you that there's that PE file kind of module for Python, there's a whole bunch of other very useful modules for Python. It allows me to do a bunch of work in Python for extracting data and then put that data into MongoDB. So without having to convert all of my commands over to JavaScript. So this is like a really good example of I'd like to create a new database, and then within that database, I'd like to create a collection called malware. So if any of you are familiar with SQL, SQL has a concept called tables, or a data structure called tables. Mongo doesn't have tables, but they have collections, and I think that's mainly because they you don't end up having a structure defined or a schema defined at the collection level. So the collections are not going to be square or rectangular. They're not going to be tabular. They're actually just going to be like, think of it more of like a bag where you scribble a bunch of stuff on note paper and then you throw it in the bag, and you scribble something on note paper, you throw it in the bag. That's the approach that MongoDB is giving you. So I'll do this. I won't grab all of these, or I don't necessarily need to grab all of these features. Or I could. I think I actually might be able to. So let me see. I can't remember. Yeah, I think it's here. So this would be the get PE data. I'm trying to see. I can't remember if I have this. So, well, this is just the PDF parser. So, anyway, yeah. So this one was kind of like a rough idea of using similar. The Python, this is basically an example of doing that kind of data extraction with Python, but using the PE file module that I showed you earlier. So what I can do is I can take what we are getting out and I can start at least importing some of that information into the database using basically a very simple kind of script to give you an idea. So for instance, let me see. Actually, you know what? I do have this. Give me 1 second. So here it is. It's this tool, actually. So I'll run this tool. And let me just double check. It does have Mongo. So this one's like this code. This is actually online. I'll make sure that it makes it into the lecture notes for this week, but it is in the lecture notes for last year as well. So basically what this does is it, I'll run this again and show you what I'm talking about. Exceeder, and then, right, let me go back up to, here we go. This was the one I was looking at, right? So what's cool about this one is that after a lot of the, so that this data that I'm showing right here, up to about, yeah, here or something. So up to about here, this information is embedded in, is basically binary data that's embedded in the header of the file, a lot of which is very particular to the compiler and linker that was used. This information underneath is actually information that the, say for the most part, I won't say entirely, but for the most part, this is all information that the author of the malware would have added in the Visual Studio project. So for instance, somebody wanted to be clever, and instead of saying that the file description for this is malware, they decided to say the file description for this is inbox toolbar setup, product name. Somebody wrote this utility which was originally designed to extract a lot of the metadata that's hidden in a lot of your images. So like your camera takes a picture. A lot of times what happens is the camera embeds its own model number in the picture. If you happen to be using a phone, sometimes it'll embed the GPS coordinates in the picture. So for those of you who like to post photos on Twitter, that might be a handy piece of information. But they like to post all sorts of extra data and stuff like that in photos, right? Somebody wrote a tool to extract that information. The tool was very nice and very modular. So somebody else said, hey, other files and images have metadata. I'm going to make a module for that tool that extracts metadata from all sorts of other files as well. So even non-image data. And so then this tool that still has in its name exit, which is a standard for metadata that's very particular to images and media, is now a multi-purpose tool that I can use to extract a whole bunch of features from malware.
Is there a Windows version of it?
Which one are you talking about?
Exit.
Oh, is there a Windows version?
Yeah.
So it is a Perl program. So yes. I've not used it in Windows, but yeah, it's in Windows, especially we can look at the tool Windows. There might even be some, the reason I'm doing this is there might even be some Windows installation, right? Yeah, here you go. How to install on Windows. And you can even download the Windows executable. So they have the entire thing bundled as a standalone executable as well if you want to use it in Windows. So what I'm going to do is I'm going to what was that? There we go. Here we go. Whoops. For anybody who likes that popular XKCD comic. Oh, it still doesn't think it's on there. Oh well. Let me see if I can. Oh, you know what? Apologies. Thought I had this on there, but I didn't. Different version of Python. So now it's working, right? So basically give it a file name. So I'm going to give it, how about if I give it that file we were working on before, this one? So now it's telling me that it added all of this information to the database, right? So what I can do is if I use the Mongo shell, I made a database that's called CS7038 so that I would kind of stick to what was in the slide. So then I have a malware collection. So what what Mongo does is it allows you to basically run find queries, and then it'll give you JSON results. And those JSON results are usually in the form of a series of what they call documents. So in this case, this right here is a full JSON document structure or whatever. And if I leave it highlighted like that, I think it's easier to view in class anyways. So what I've got here is it already assigned a unique object ID to it. So just like you can have like the auto index row ID thing in SQL, MongoDB automatically assigns a unique identifier to every single object. But then it ran the Md5 checksum, the SHA-1 checksum, the SHA-256 checksum. So all this stuff is code that I have in that metadata import. It identified the file size. It added the name. So I gave it a file, right? So it actually is now keeping, it's still useful to keep track of the names we saw that file as, it's just not very useful to use that as a unique identifier for a file. But basically it's pulling a whole bunch of metadata from that exif tool output. So very similar to what we did with objdump. It just happens to be using a different data source to get all that information. But you can see the file descriptions here and everything. So the nice thing that I can do with this is I can find anything where maybe type contains, so I should say is win32exe. So I can have it query for that, and then I don't get anything if I'm, if nothing matching my data type is actually present in there. So then what I can do, if I want to, is I can actually run this whole thing on every single file that's in that folder, right? And so then it'll run through here and it'll start pushing all that data into the database. So while this is running in the background, I might be able to jump in here and now I have a bunch of different malware samples in here, and I can actually get a count of all of them, right? There's like 53 in here. So one of the reasons, or I should say, one of the things that is really nice about this as well is that I can maybe identify something like this. So company, right? So company name was put in there. So I might want to do distinct. And so that shows me a distinct list of all the different company names that showed up in my malware samples. So then,
can you read the last one?
No, I can't. And so then, what I might want to do is do this. Was this it? Or I should say I can do this. So it tells me there's like 17 of every one of them. So I can see like itself is one of them, right? So I can do db.malware, .distinct company. And the reason I'm doing this is just kind of showing you that, oh, yeah, here we go. And so now, basically, I narrowed it down with a search query that's looking for just this to basically, and that, of course, shows only the ones that have itself. So, for instance, I could even do this, right? I can't remember. Let me do this. What is it? Type. It's really just type. So I can also do this and have it give me a list of the different file types and everything like that. So the idea is that as I write more analyzers, so in this case, now I've managed to fill up my malware database, so to speak, with 98 different files, right? So 98 different entries. So now I have a system set up where if I want to, I can uniquely identify them by the checksum, right? So if I happen to write other analyzers, I can have something that goes in there looks to see if maybe this checksum is already in there. And if it's in there, then I just add, say, the missing information to it that my analyzer adds, rather than creating a whole new entry, or rather than having to wipe everything out and then run all of this analysis plus my new analyzer's output on it as well. And so that kind of sequence of steps is where I find it's very helpful to have or I should say to leverage tools like this when you're doing the analysis work, and especially when you're, so in this case I've got I think in total I have 10,000 samples in that one folder. So, right, so I have 10,000 samples in here. It's far more than I can possibly, analyze just by myself. So what I would do is I'd come up with kind of bulk analysis tools to try and see if I can identify correlations and connections between all of them. I'm just going to try and see if maybe file description. So yeah, so you can see that even here is there's 29 of them, right? So, and then there's that inbox music, inbox setup. So maybe what I'd want to do is look up all the ones that maybe present themselves as setup. Right, and there's 8 of them there. So and so there's 7 different variations, which means that maybe, so then I might do, I can't remember, let me do this. So I might want to do some J. So turn that into a semi-dictionary or something like that. I think I can do that in JavaScript. And then I do so basically I can programmatically go through and I'm not even sure if this J is undefined. I always end up acting like I'm using Python when I'm really not. But anyway, I can't exactly remember how to do that construction in JavaScript. But for, I could probably just do this, right? So if you remember, each of these would be basically index corresponding to the counts. So what I end up having is that there's 1, 2, 3, 4, 5, 6, 7. So there's 7 labels, and then there's 7 kind of counts. And what I ended up doing was running a loop across it to say, okay, give me all the distinct values for the file descriptions. Now I'm going to take each one of those and run them up against the database and have the database tell me what the frequency is of those file descriptions showing up in my data set, right? And what I ended up finding out was that all of them only show up once except for this one, toolbar powered by inbox setup. So there's a bunch of different variants, and a whole bunch of them have to do with toolbar, but only this one actually happens twice, which means maybe I have two different malware samples where the author just happened to choose this name both times. So that itself might be something worth investigating. And so when you're going through, in this case, when you're going through a lot of different files, and I went through 100 different files, one approach to trying to attack the malware analysis problem is trying to identify like commonalities like this that then will help you kind of divide your pile, divide your sets up into different groups or different organizations. So for instance, this one, just do this very quickly. It's going to give me these two now, and so I can go through it and I can see that one of them has this company name and the other one also has this company name. So now I have two data points where they're kind of sharing something. Additionally, the sections that were used, you'll notice don't necessarily use the same naming convention that we had seen in a lot of the Windows programs we're using before. I don't know if that was picked up earlier, but a real common, I should say, saying code data BSS like this. That's not commonly used in Visual Studio.
That's a different IDE.
Yep.
Yeah.
And so then there's this timestamp up here, which I pointed out earlier. I don't know if anyone knows what IDE that is, but so it's Borland Delphi.
Yes, I think.
Yeah. So for whatever reason, Borland Delphi always, or very often, will set the creation time to this weird 1992 date. But that gives me some insight into that the person who wrote this program, for whatever reason, felt that this information would be useful information to convince their targets to open the malware. And then they build their malware with Borland Delphi. And I think that this timestamp may vary from version to version or something like that. But that's a real common. I really don't know what the reasoning is behind that, but that happens a lot. The other thing we can look at is size. So sometimes we can learn a little bit about two programs from their size. For instance, if two programs have a very similar size, then that might more strongly correlate to them being maybe the same type of malware, right? So in this case, they might be the same type of malware, maybe with a handful of features that were compiled into one and not in the other, or maybe with a different icon file or something like that. So a lot of different avenues to go and search with that. And just like, this was a real quick and dirty script. It was written in Python that actually extracts all this stuff. So I'll see if I can bring it up. Well, I guess it's at the end of class for the day.
Is that the size of the malware in memory or on disk?
That would be the on-disk size. So the size of malware in memory I didn't end up recording here, but I actually can't remember if that is encoded or not. Because can't remember if the size is actually embedded in here or if that's just computed at runtime. Yeah, no.
some tool called
This thing.
the virtual size.
Yeah. So this thing would probably be the size of the image, is probably the value that you're looking for. And that's supposed to be the, you know, the amount of space that I believe it's supposed to take up in memory when it's loaded in memory. So, in addition to that, there are these other sizes as well that you'll notice down here, which tells Windows how much dynamic memory to allocate and reserve in each of those spaces as well. So.